Bismillahirrahmanirrahim. Assalamu alaikum. This is lecture 6 and we continue with our topic on highway drainage. So, one of the important structure for highway drainage are the drainage channels and obviously the side slopes. You can define drainage channels as the channels that are provided along the length of the roadway for taking stormwater drainage, or you can say a rainwater from the pavement surface. So what are the requirements of drainage channels? Drainage channels should have an adequate capacity for the design runoff, minimize damage to the highway caused by unusual stormwater, minimize risk for motorists so they don't feel getting into that or they don't fall over because of some inadequate structure design. It should be resistance to the high speed water flows where expected, and it prevents sedimentation of the particles carried by water. So the design consideration for highway drainage include, but not limited to, safety, good appearance, control of pollutant, and economy in maintenance. How we can achieve is by doing these things: providing flat side slopes, the drainage channel should be wide enough, and the rounding of the corners. Now let's take an example how the drainage channel looks like in a plan. So this is my roadway structure, these two lines, and then along with this line the roadside channel here. So obviously the slope of this road section will be going here. What I mean, this portion of the highway is being raised with respect to this. So with all the water coming from the rain or the surface should go here. Now, not only that, there is an intercepting channel, and this channel is also running. Now this channel is taking care of what? It's taking care of the water from the surrounding, from the adjacent tank, and here water is collected from the ground, from the surroundings, and they meet at this point. And this can be connected to the drainage, to the roadside channel as well. So remember, this channel should be wide enough not only to take care of the water from this road surface, but also to take care of the water coming from adjacent buildings or land towards the road. So the point where the side drain, roadside channels with an interceptor drain, we call this as toe of a slope channel. Now let's look at side slopes. Steep side slopes improve hydraulic efficiency and reduce right-of-way cost. Flatter side slopes improve stability and traffic safety, reduce maintenance cost. If you provide slopes 1 to 4, a good chance of recovery for errant vehicles in direct driver tension. Roadside channel is visible to the driver. Side slope of 1:5 or 1:6, I mean 1 vertical and 5 horizontal, are recommended in the flat areas. Those intercepting channels have a flat cross sections from a dike made with the borrow material. Hidden drainage channels are also shallow depressed areas within the inlets. Flumes are open channels or pipes used to connect intercepting channels or shoulders curves with roadside channels. Channel lining prevents channels erosion caused by fast stream of water. Nowadays, channel is also lined with a geosynthetic material, so not only it makes it waterproof, but it holds the sides of the channels, not allowing it to erode. The typical example of side slope would be a grass. It is where it is possible. Then there is a concrete, stone, etc. The problem sometimes with the grass is the maintenance. If you do not maintenance, this grass will create a problem, and there may be some uh, some animal hiding there, or this. So it's not very good. Now, what we do in side channel of side slope and what we need to do as a safety is the following thing. We have rounded hinge points that can reduce the chance of an errant vehicles becoming airborne. For side slope, factor can be negotiated by errant. So, in order to have this errant vehicle control, a side slope of 1:5 or 1:6 is always recommended. Then there is a force slope, 1:3 with liberal rounding, provide a good chance for recovery. Slopes cheaper than 1:3 can be used only when used justified by local conditions. The use of roadside barriers should be considered. Maintenance consideration, flat and well-rounded side slopes simplify establishment of turf and its maintenance. Slope 1:3 enable the use of motorized equipment. Other rules of side slopes. Flat, well-rounded side slopes create a streamlined cross-section. Advantages for the dead sections are naturally pleasant, natural present appearance, improved safety consideration, snow drift prevented, easily maintained. There are retaining walls that should be considered where slopes would be steeper than 1:2. So if you cannot provide a slope of 1:3, 1:4, consider to have a retaining walls. Standard slab for rock cuts 2:1 is good quality rocks, ranges from 6:1. So sometimes you have to cut the slope, but you have to cut the slope in this ratio 2:1. Now here is the description of the side slope. So we start with the traffic lane, and then there is a shoulder. And the point where the shoulder and the storm drainage water meets, it's called a hinge point. Slope going towards the drain from the roadway, we call this as a force slope, S1:1. Then obviously there is a slope within the channel that we call a pitch slope, and the point where the force slope and the slope of the channel meet, it's called the toe slope. And now this is the side that is coming from the land side, so that we called a back slope. So the difference between a force slope and back slope, force slope is from the traffic, the water from the traffic, take care from the water from the traffic, and the back slope is taking water from the adjacent land area. This weight is variable, it's very important. The more the weight, obviously, the more water it can take, and also now, but at the same time, it may be economical. Sometimes if you don't have much rainfall, this width can be small. But for an area where higher rainfall is expected, this can be wide. There are the other examples of the side slopes. So this is for an rural areas where there is no building around, so you have a section like this. Similarly, if you are constructing a road channel within the urban setup, you can see this as the building line, and with side slope there is a depression over here. The channel is like this. And sometimes not only you have a channel, but you also have a pipe to take care of an extra water. This is the example. This is your drainage channel. This is your intercepting channels. This is another example of the roadside channel. It's a truss, as I've told you, it's stuffed, so water, some amount of the water is absorbed by the trough, and the remaining is gone, is allowed to pass through this channel. So this is the channel. So it's not only it's a road, it's a median channel, you can see. This is a two-way road. The this channel will take in water from this side of the road as well as on this side. Then there is a drainage channel known as curved highways. So the minimum slope varies from 1.25% with intense rainfall will cause wide sheet of water on the curved travel. Or possible improvement maybe have parabolic cross sections with increasing cross slopes. Gutter along the curve with the cross slopes larger than the of the traveled way. On a multi-lane highway or multi-lane traveled way, cross slopes broken along traffic line edges, increasing from minimum value of the innermost lane up to a maximum value on the outermost lane. This solution is used in uncurved section as well. So this is a typical example of curved section. You can see this is a curved stone and there is a depression in it. On both sides of the road, obviously the parking is permitted. So on this side you may not provide gutter, but on this side you provide a gutter. Another type of drainage is a subsurface drainage. What is a subsurface drainage? We can define within these lines, moisture changes, the subgrade occur due percolation of rainwater and seepage flows, as also due to the phenomenon of a capillary rise. The aim of subsurface drainage is to keep the groundwater table sufficiently below the level of the subgrade, at least 1.2 meter. When the water table is almost at the natural ground surface, the best option is to raise the formation of the roadway on an embankment such that it takes 1.2 meter above the ground. I give you a very simple example for that. If you are constructing a roadway along the water channel like river or lakes or ponds, you must raise the road level at least 1.2 meter or 4 feet from the surrounding. That is, the road level should be at least 1.2 meter high. So what would it do? it will control the phenomena of capillary rise, and the water may not rise up to 4 feet to wet the pavement from the bottom. Now, if this is not possible because of the unfavorable topography, the only option is to lower the groundwater by means of subsurface drainage arrangement. It must, however, be remembered that only gravitational water in the soil can be drained, but not held water, which is made up of the moisture film around the root. This is one typical example of subsurface drainage type. Now what you do, one option is to install a drain in the previous layer, pervious layer, by beside the road to intercept the groundwater before it can reach the subgrade as it shown. So there is an impervious layer where water cannot be passed or can be hold on. As a layman, you must understand this is a layer not normally made of clays and like material. So what you do, you provide a pervious layer. This may be of gravels. And what you do, you excavate a trench like this. You have a pipe that we call a perforated pipes. It is so designed that the minimum that the opening should not allow a minimum particle size of around say 0.075 mm to pass through it. Otherwise, if the size of perforation is larger, then the silt will also go and this can choke your system. So what happens here? How does it work? It's the water from the pavement comes to this surface and then it goes like this, and all the water coming from the side of the land side, it enters and it is intercepted. So this is one way to intercept a seepage water that is coming from the adjacent buildings. Now, if the problem is complex, then you have to provide these trenches on both sides. And what this step is dependent upon the groundwater table. So still we have to raise the pavement by 1.2 meter. So once what you do, you have to have at least this depth more than 1.2 meter. What you do, you build trenches here and here. Once your pavement section is complete, and then you fill this trench. First you lay a sand cushion, and then over it a perforated pipe, and then there are gravels, and then there is a impervious clay seal. So remember, and this is your surface drainage. So what happens, how it works? The water from this carriageway will not be allowed to enter here, but this water may be entering from this point, going down, and at the same time water also be going through this stormwater drainage as we have discussed. Now similarly, the water from this side will go on this side, and from the other side of the building the water will enter here. First the water as well. So what happens, that water will not be allowed to enter this area. So this water, once the water is there, some of the water will go there, some of the water will go there, some may have this right. And gradually, once you have built this groundwater will also be lowered because all the groundwater will now seep through these trenches. And then they will be collected from the pipe. These pipes may be connected with the interceptor drains, and those interceptor drains will be connected to the water course, whatever the drainage infrastructure you have. Sometimes providing longitudinal pipes may not be enough. So what you do along the length of the roadway, what you do, you also connect these pipes to these longitudinals. So what is happening now? The water will be lowered. When the water goes down, it will be intersected by these pipes. These pipes are staggered for economic reasons. So some water will go here, some water will still seep through, it will go here, this will be intercepted by this transverse drain. Again, these are perforated pipes wrapped with geotextile material so that no clogging occurs. And then once you have done this, this will allow your water table not to come onto the surface, beneath the surface of the pavement. This technically also known as a fresh drain. Another way to prevent groundwater table wetting the pavement subgrade or subbase. Now, if your subgrade is clay, the system on either side will not be effective. In case of very low permeability of the subgrade, such case, the subgrade has to be raised with a free draining material or capillary cutoff as shown. This is a capillary cutoff. May even of bituminous layers or location should be above the level of capillary expected from the clay subgrade. So when we were talking about the trenches in the previous slide, what we're taking, we were assuming that the surrounding groundwater table, surrounding ground topography was not clay material. But this is not the case here. The clay material around, so you cannot have a French drain as discussed because this will not allow water to come inside the French drain. So we'll have to do this thing. Mind you, this is a cheaper solution as compared to the French drains we were constructing. So sometimes seepage water renders cut slopes unable by reaching the face of the slope. This can be prevented by lowering seepage line or providing a subsurface longitudinal drain installed to a depth below the pervious layer. If the pervious layer is more horizontal drains comprising perforated metallic pipes or PVC pipes installed at suitable slope may be provided to serve the purpose. This is the ground slope, and here we have provided a drain. This is the road surface. The water is now coming directly to this slope, and this is the water. Water from this side we want to prevent entering to this. Another type of a drainage system is what we call a cross drainage. So roadways have to be aligned to cross natural drainage channels, streams, and major rivers. Sometimes the alignment will cross man-made channels like those for irrigation. In such cases, the need for constructing cross drainage structure arises to ensure the water flows beneath the road without causing any inconvenience to the highway structure. 5 major types of cross drainage works: culverts, minor bridges, medium-sized bridges, major bridges, and causeways. Typically, it is the width of the water channel. So, if the width of the water channel is less than 6 meters, the structure that is provided, the bridge structure, is known as culverts. Then 60 to 30 meter, it is called a minor bridge. Then medium-sized bridge and the major bridge. And the main difference is also the height of this structure from the water course. These are typical example of the cross drainage work. We have a pipe culvert. So this is a structure and the water is allowed from the pipe. Another way is to have a box culvert. There is an arch culvert. Now this whole section will allow water to pass. And there is a slab bridge in which you will allow water from the side. Depending upon the capacity, we can have these cross drainage. People are often confused between a culvert and a bridge. So any bridge that is less than 6 meters long, as you can say, it is a culvert. The rest is a bridge. A culvert, height of culvert is lesser as compared to the height of the bridge. Technically speaking, the bridges, as the height of the bridges increase, the cost also increases. As we have seen in one of the diagrams, that the popular culverts are masonry arch, slab culvert, pipe culvert, and RCC box culverts. Then there are causeways. The bridges, the difference between bridges, causeways, and culverts, or we'll say even the culverts and the causeway. The bridges allow water to pass under it. Causeways, in some circumstances, allow water to pass over it. So again, we can say the height of the causeway structures are lesser as compared to the culverts. This again, these causeways should not be provided for a very highly important structure. It is only for small roads, small railroad roads in village areas or rural areas. So as I said, causeways allow water to flow over them when the stream goes to see floods. These are provided on relatively unimportant roads with small volume of traffic. Sometimes you have to close the traffic 15 days but it's our desire to not to close them at more than 3 days. Depending upon the degree of interruption, we can have a high level causeway or low level. The concept is sometimes we raise the top of the causeway to a expected water level rise. Just like we had a rain in Karachi, and one of the causeways near Baloch colony, it got overflowed. But mind you, for me, it is a high level causeway. Most of the time, you don't have to cross the road, but if the floods are exceptional, then this causeway are damaged and they cannot be open to the traffic. And then, as the name suggests, there are low level causeways. They will be designed at least for 50% above than the expected water level. So it depends upon what level, how you raise your structure. High level causeway is submersible rail bridge. to overtopped in floods. Its formation is such a way that not to cause interruption to traffic during flood more than 4 days, 3 days at a time, not more than 6 times in a year. They are provided with abutments and piers, floors and slabs to form the required. The slope of approaches kept was in 1 in 20. When velocity is high, the aprons of concrete hardened up to a certain distance, then the road can be formed of cement concrete or stone block set in the cement block. A sufficient number of openings are provided to allow the normal flood discharge to pass through them with the required clearance. A low-level causeway provides a bridge when water flows low. Under high flare condition, water runs over the runway and it stops the vehicle traffic. This approach is cheaper to raise the level of the water above the highest flood stage of the river, particularly in developing countries or in semi-arid areas where rare high volume rain do occur. Low water crossings can be dangerous when flooded. And most of the time, you must have heard the road has been blown away and it has been damaged, it has been washed away, and this is where the most of the cases of low-level causeways. So that ends my lecture on highway drainage or highway pavement. One thing is to be noted that I have not discussed how to design a highway drainage structure because of two reasons. One reason is simply the present course, the content of present course does not give more weightage on the designing aspect. The other is in urban engineering, we have a dedicated course, municipal drainage design like this, and that covers the design aspect of this stormwater. So you will learn in future how to drain it. That's why I've limited my discussion on drainage just for two basic discussions and have not focused the design aspects and how to design this. Before I move ahead to our next topic, I have decided that for midterm, this is your course. So from introduction to the highway drainage, your course content for midterm is from these lectures. Shortly, I will be giving you some assignment that may have a deadline so that you can fully study, fully understood the concept of not only the pavement design, but the simple definitions related to highway drainage. Now, the next topic, airport. As you know, transportation there are different modes of transportation. Highways, railroads, they are land transportation, and then there are airports. They are airborne transportation. Then there you will obviously study waterway transportation. So let's discuss about the airport in detail. So what I mean by an airport? An airport is a facility where passengers connect from ground transportation to air transportation. Other people define an airport as a location where aircraft such as airplanes, helicopters take off and land. Aircraft may be stored or maintained at an airport. Airport should have a runway for takeoffs and landings, buildings such as hangars and terminal buildings. An airfield or a runway is an area where an aircraft can land and take off, which may or may not be equipped with any navigational aids like marking or all those lights you see in a normal runway. And many grass strips are also designated as airfield, but this is for a smaller aircraft. For now, aircraft for nowadays, you don't have an airfield of a grass strip. This is what I was talking about. All these things are navigational aid, and you can see those lines, the guidance lines, and then there are. These airports are also known as aerodromes as well. So, a defined area on land or water, including any buildings, solutions, and equipments, intended to be used either wholly or the part of the arrival, departure, and surface mode of the travel. An aircraft can land on water, but obviously we need a special type of aircraft, and that is not a commercial aircraft; it's just a personal aircraft that can land on water. You cannot take risk of landing your whole aircraft on water, especially the commercial flight, because there are many people who flight. This is a very good picture of our Karachi airport. So the first airport was built in 1928 at Croydon near London. It was closed in 1959. Now it is used for amusement purpose, for people visiting and see how does it like. Now, what are the major group activities in aviation? In airport? So there are regulations, there are air traffic surfaces, there are airlines, obviously there's an airport. These are the airlines generally operate on Pakistan. There is one more, there is Serena, that I have missed out. Serena is the latest addition to our airline. There used to be another airline, AeroAsia, but it has been closed. So right away there are these kind of it. And this is example of other airlines operating in the world. Cathay Pacific, Australia, Qantas, Canada, the Korean Airways, the Malaysian Airways, and then is a British Airways. What are the regulation and policies that dominates, that are prevalent at an airport? All these are the responsibility of ICAO, International Civil Aviation Organization. So what does it do? ICAO creates regulations for aviation safety, security, efficiency and regularity, and environmental protection. The organization also regulates operating practices and procedures covering the technical field of aviation. This collection ensures smooth air transportation and border crossing procedures and ensures. So you can ensure full fair opportunity to operate international airlines, promote flight safety, and minimize expenses and penalties. This is ATS. With the crash of an unfortunate PIA just recently. This ATA has been highlighted everywhere. So actually, what does an ATS do? Air traffic services help in navigating aircraft while landing, taking off, flying in the air, overflying, and country taxiing on the ground. So this ATS control every aircraft coming out of going out of the airport and coming out. They provide a discipline in the air and also on the ground. See, the services are provided by using modern equipment, including radar. Now, the general classification of airport. Airport can be classified into three categories: international airport, domestic airport, and regional airports. So we have 12 airports that can be categorized in international airport. Although I would say there are only 5 airports that are truly international airports. Otherwise, the airport that operates in Hajj fly in Pakistan, we call them as international airport. But mainly 4 to 5 airports that actually categorize it. Karachi is one of them. Karachi, Lahore, Islamabad, Sialkot. These 4 and maybe Peshawar. What is an international airport? Has direct services to many other airports, handles scheduled commercial airlines for passengers and cargoes. There are many airports that are also known as hub and spoke airport. What does that mean? Is that, there is no direct flight. What happens is that one of the aircraft carrier, take example of Emirates Airlines. If you want to go, say, Australia, first this Emirates Airline will take you to Dubai International Airport. And from Dubai International Airport, you will be transported to your destiny or Australia, as I've exampled. Now, what is the advantage? If it would have been, say, direct flight, and say it have passengers maybe lesser than the capacity, it would have a lesser profit ratio. So what happens? What Emirates do? Emirates collect all the passengers for the same destination. People from India, people from Sri Lanka, and then they bring all of them at Dubai International. At Dubai International Airport, all of them are being allowed to sit on airplane going towards your destination, Australia or wherever. So this is a very profitable airport, but they are very large airport. They carry bulk of passengers. There are many passengers coming into it, and for being a passenger, it's it's an hectic thing, because first shifting to one aircraft, then waiting at the other airport, and then going back to the again. You don't come directly to the home. But for airline industry, they have more profit by earning service. So typically, international airports are equipped with customs and immigration facilities. Such airports are usually larger, feature long runways and facilities to accommodate the larger. Then there are domestic airport. Now, domestic airport is an airport which handles only domestic flights. They do not have customs and immigration facilities like we are going to Lahore, Islamabad, Pindi from Karachi. These are domestic operations. Obviously, they do not entertain any flight from the foreign country. Most of the time, the national flag carrier is the one that have domestic responsibility. These airports normally have short runways which are sufficient to enter short, medium, or sorry about this mismatch. Islamabad is an international airport, but just a second, just the shape of an airplane. This is an Sialkot. Then there is a regional airport, subway traffic within a relatively small or lightly populated geographical areas, does not have customs and immigration facilities, tends to smaller business jets or private aircraft. One example is the airport owned by PPL in Sui. There are other airports as well in which the private businessmen have their own crafts, two-seater or four-seater, and they operate it. Now, who owns an airport? Classically, it is the Civil Aviation Authority of any country. We have this we call this as Civil Aviation Authority, and then there are different names of this civil aviation. What does civil aviation do? Civil aviation follows the rule of ICAO, and also within its framework, it also has responsibilities to take care of any matters related to airports within Pakistan. How it is managed, or who are the stakeholders in airport? There are what we call it airport operation services that includes security, fire, rescue, and maintenance. Then there are airport planning and development. This is where the civil engineer and mechanical engineer and urban engineer, they can be employed. And then there is an airport financial revenues, talking about the business, accountants, all other people of these trades comes into this category. So the prominent objective again to ensure the operational safety and security of the passengers, cargo, and aircraft operations. Now this is the last slide. We call this thing as airport activity. So there are two main categories of an airport activity at airport. There is an activity called landside activity, and then there is an airside. And in between them, there is a transition. So I start with the landside. For instance, you want to go somewhere outside your city, maybe within the country or outside. What you do? You come either from your own car, park it, or you take a ride from your friend or family members. They drive you near the terminal building. Once you have entered the terminal buildings, you go to different processes. Security, baggage checks, boarding card, and then custom facilities, all you do. And once you are over it, you go to your desired designation, to the desired gate, as we say, to get seated in an aircraft. So this point where you are being translated from terminal building to the aircraft. Now here we can say the transition is changed. Your category will be now you will categorize as an airside movement can be airside movement. So what happens? This aircraft get loaded with cargo and passengers, and it started moving towards the runway. So this portion where aircraft is with park for being loaded and unloaded, this is known as an apron. And then connecting a link pavement from an airport, from an apron to the main is known as apron. So what happens is here, aircraft is being towed and then from its own power, it takes this way, this is called a taxiway, and it enters a one way, and then obviously it flies on it and it takes the speed and it flies off, takes off. So this activity is an airside activity. Now vice versa. You have come from another airport, from another place, you have landed, and the aircraft will take you to this terminal building. How? Again, by using this taxiway. This taxiway have different configuration. This is an right angle exit taxiway. This is an acute angle taxiway that we will discuss. So what happens now? This aircraft taxiing off, and it will come and stop near the parking building. And from terminal building, the passengers will go into the terminal building, take their baggage. If they are international passengers, they will complete their passport documentations, all of them, and then they will go out of terminal building and they take a ride back to their destination. So once again, the same thing with a different approach. One we called our departure and the other is called arrival. So what happens? Let's see how you depart. You have come from the local roads, the parking areas, to go into the terminal buildings, and then there's a departure concourse, then to the gates, and from gates, the concourse means the connecting area, to go to the place where you will sit and wait for your aircraft to get ready. Then you will use the gate, go to the apron. Either directly you enter from airport, you may directly enter into the airplane, or you be taken from the gate, you be taken from some bus service to your desired aircraft, and then the place where the aircraft has been waiting is called apron, and then from apron to taxiway and runway, and you can see the mirror image on the other side. So this is what the main flow chart of buildings of an airport. So where do I start? Okay, I start with a taxiway. The aircraft has come all the way and now it is taxiing. It will go either here or here. This is a short route, but sometimes what happens is that there is an aircraft already over here. So this aircraft has to take this short route and it go to the passenger terminal building. And obviously there is a control tower somewhere here. There is high expectation. There are other runways. There is a maintenance hangar. Hangar is a place where aircraft is being overhauled. It's being checked. It is being stayed when it's not in flight. And this is the parking areas for the vehicles. Then there is, boarding walkways. This is a terminal building, circular in shape. So the aircraft is like here. So with this, I'll conclude my lecture. In lecture 6, we have covered 2 topics. One is the highway drainage. The other is just introduction of airport. So I stop here and hope you have enjoyed this lecture. I have understood very well. Thank you very much. Allah Hafiz. Wish you all the best.